Spectroscopy, NMR spectroscopy. So already we have seen instrumentation, theory and instrumentation of NMR spectroscopy, and we have come to the conclusion that you will get a spectra from the instruments. So at the one side you will be having 0 value, another side it will be having 10 value. So 0 delta and here 10 delta. Okay, and there will be some signals will be appearing there, doublet, triplet, whatever may be. So now, how to interpret this spectra? We have already seen that. Now, so how to interpret this NMR spectra? Here there will be values, delta values 1, 2, 3, and so on up to 10. So how to interpret this spectra? In this spectra, we have to see 4 things. Number 1 is number of signals. Number of signals. Second point is position of signal. Third point is, which we have to see, that height of signal. You will call it is a integration curve. Fourth one is splitting pattern. You will call it as a spin coupling. Spin coupling. Position of signal, it is called as chemical shift. And number of signals. So these 4 points we have to consider while interpreting NMR spectra. First point we have already discussed, but revise once in a short, and we'll go for another second factor. Before going to the first factor, number of signals, you are requested to join YouTube, subscribe it, and as well as press the bell button so that the new upcoming event will be intimated to you. तो जब भी जो आप हमारा जो YouTube का चैनल है आप उसको सब्सक्राइब कीजिए और उसके साथ बेल बटन को है तो आपको प्रेस कीजिए, तो आपको जो आने वाले जो इवेंट्स है उसकी जानकारी आपको लाइव मिल जाएगी, रियल टाइम में आपको इंफॉर्मेशन मिलेगी। हमारा चैनल है Dr. Pathan, ये चैनल है, इसके ऊपर YouTube के ऊपर ये आपको वीडियो अवेलेबल रहेगा, ये वीडियो भी आपको अवेलेबल रहेगा, ठीक है, इसकी रिकॉर्डिंग अवेलेबल रहेंगी, तो आप है तो उसके ऊपर भी ज्वाइन कर सकते हैं। तो हमारा पॉइंट चल रहा था यहाँ पर नंबर ऑफ सिग्नल्स, ठीक है। तो नंबर ऑफ सिग्नल्स, दे आर डिपेंडिंग ऑन द नंबर ऑफ टाइप ऑफ प्रोटॉन्स प्रेजेंट, जितने टाइप ऑफ प्रोटॉन्स प्रेजेंट है, प्रोटॉन्स, ठीक है, टाइप्स ऑफ प्रोटॉन्स। नाउ suppose we are having CH3 group, so C double bond O single bond CH3. Now see here, in this compound there are 2 CH3 group. Now there are 3 hydrogens attached to 1 carbon. So we will start again. In we are dealing with is NMR spectroscopy, and we will get a spectra from the instrument. That instrument is giving the spectra. That spectra is to be interpreted, and for interpreting this spectra, we have to look four factors in the spectra. First is number of signals, कितने signals उसके अंदर present है. Second one is position of signal, that is called as chemical shift. Chemical shift will be the another second factor, important factor. Then height of the signal, that is called as integration curve. So that will give the number of identical protons. Splitting pattern, that is the due to the spin coupling. So these four factors जो है इसकी वजह से हम है तो की मदद से हम स्पेक्ट्रा है तो यहाँ पर इंटरप्रेट कर सकते हैं. तो पहला हमारा चढ़ा था फर्स्ट पॉइंट विच वी आर डीलिंग विथ नंबर ऑफ सिग्नल्स. नंबर ऑफ सिग्नल्स, you will get a signal for a proton. Now, those protons which are having same electronic environment, yani electron distribution with the hydrogen is similar, that is identical, then that protons will be clubbed together. What I mean to say that here in this particular example, like here CH3, C double bond O CH3, there are three hydrogen atoms with the first carbon, C double bond O, second carbon is also having three protons. If you compare this hydrogen atom, second hydrogen atom and the third hydrogen atom, you will find that these three hydrogen atoms, they are attached to the carbon, which is having same electronic environment. Electron distribution, electron density is similar with these three protons. Therefore, the absorption frequency of these three protons will be similar. ये तीनों की absorption frequency similar रहेगी. Therefore, they will appear at the same position. Means these three protons, they are identical. They are same. So they will be clubbed together. They will form a group. Okay? तीनों का है तो एक ही जगह पर single position. They will appear at the single position. ठीक है? एक ही position के ऊपर ये मिलेंगे. See another CH3 group. CH3 is having three protons. These three protons, CH, again these three protons, they are identical. They are same because they are attached to the carbon. The carbon is next having carbonyl group. So these three protons, they are identical. So the position of this proton, the absorption frequency of the second proton, and the absorption frequency of the third proton, all these three protons will be equal. So you will get a single signal for these three protons. ये इसके लिए आपको कितना मिलेगा? एक सिग्नल मिलेगा, एक सिग्नल, because the absorption frequency of these three proton is similar. अगले पॉइंट पर यहाँ पर आ जाइए. Here CH3 group, that is a CH3 group attached to carbonyl. Next is CH3 group, isn't it? CH3 group को क्या है यहाँ पर? C double bond O CH3, that is acetyl group है. अगर ये CH3 को देखें यहाँ पर, तो इसको अगर हम देखेंगे तो क्या है यहाँ पर? C double bond O CH3 means इसके इस साइड में जैसा सिमिलर ग्रुप है, इसका सिमिलर ग्रुप इस साइड में है. Means here these two CH3 groups are identical. They are having same electron densities, electron distribution. Therefore, these two CH3 groups are same type. Therefore, you will get only one signal for this CH3. तो इसका आपको एक सिग्नल मिल रहा है और इसका आपको सेम पोजीशन के ऊपर सिग्नल मिलेगा. Means you will get a signal for only one signal for all the 6 protons. पूरे तीनों प्रोटॉन, पहले CH3 के, दूसरे CH3 के तीनों प्रोटॉन, सबका मिलाकर हमको you will get only one signal. ठीक है? इसका मतलब क्या हुआ है कि नंबर ऑफ सिग्नल that will depend on that will depend on the chemical environment. Chemical environment depends on electronic environment. See here another example. CH3 single bond CH2 single bond OH. सबसे सिंपल एग्जांपल है ना, इथिल अल्कोहल. इथिल अल्कोहल. अब देखिए, here CH3 is having 3 proton, CH2 is having 2 protons, OH is having 1 proton. So see here, CH3 having 3 protons. So electron distribution will be different. Electronic environment will be different as compared to CH2. CH2 का इलेक्ट्रॉनिक इन्वायरमेंट डिफरेंट रहेगा. OH के पास का जो प्रोटॉन है उसका इलेक्ट्रॉनिक इन्वायरमेंट विल बी डिफरेंट. सो CH3 is having different absorption frequency. CH2 will be having different, and the absorption frequency of OH proton will be different. So you will get here 3 signals because CH3 is not equal to CH2, CH2 is not equal to OH. Therefore, you will get 1 signal, first signal, here second signal, and here third signal. So you will get here 3 signals. 3 signals will be obtained. Now, what about this? CH3 single bond, CH2 single bond, CH3. In this molecule, it is propane. CH3, you will get A type. Okay? This CH3 is attached to CH2, then CH3. This CH3 is attached to CH2, then CH3. Means remaining part is similar. So if it is a type, then it is also A type. Because the electron distribution, electronic environment for both the CH3 groups is same. CH2 is different. So you will get here second signal. So for CH3, CH2, CH3, you will get 2 signals. 2 signals. How many signals? 2 signals. You will get here 2 signals. So you will get here 2 signals. ठीक है. चलिए अगले और एक एग्जांपल ले लेते हैं. 2-4 एग्जांपल लेके आगे बढ़ेंगे. फिर नेक्स्ट एग्जांपल ले लेते हैं. यहाँ पर नेक्स्ट एग्जांपल वी विल सी हियर CH3 CHOH CH3 आइसोप्रोपिल अल्कोहल. आइसोप्रोपिल अल्कोहल. सी हियर कितने मिलेंगे? दिस CH3 and this CH3, are they identical? Are they same? Yes, definitely they are similar. Why? Because this CH3 is attached to CHOH, then next CH3, and another CH3 is attached to CHOH. CH3 means these two CH3. So it is A type. Then again it will be the A type. Now, what about CH? CH is having 1 proton on the carbon atom, so it will be different. It is attached to OH, so electron distribution on the CH will be different as compared to CH3. Therefore, you will be getting here second type of signal. Then here OH. For OH proton, you will be getting here third type. So you will be getting here 3 signals. For CH3, both the CH3 groups, you will get first signal. For CH, you are getting second signal. And for OH protons, you are getting the third signal. Is it clear? So you will be getting 3 signals. What about this C6H5, C6H6? Benzene. Benzene. For benzene, there are 6 hydrogen atoms attached to each carbon. So I have written here 6 protons. All the 6 protons, they are identical. They are same. So you will get only 1 signal. Only 1 signal you are getting here. Because all the 6 protons, they are identical. They are same. What about this example? CH3 single bond NH single bond CH3. कितने मिलेंगे यहाँ पर? CH3 NH CH3 dimethylamine. A A, B. You will get here two signals. Two signals. CH3, CH3. Okay. What about this? CH3, single bond, NH, single bond, CH2, single bond, CH3. Ethyl methylamine, ethyl methylamine, CH3 and this CH3. Both are CH3. Are they equivalent? Are they same? The answer is no. Why no? Because this CH3 is attached to nitrogen. This CH3 is attached to CH2. We know that nitrogen is more electronegative as compared to carbon. So electron pulling power, electron attracting power of nitrogen is more. So it will attract electrons towards itself. Therefore, these protons will be having lower electron density as compared to this CH3. So these two CH3 groups, they are not having any similarity in terms of electron distribution, electron density. So we can say that both the CH3 group, they are non-identical. So if it is A type, then it will be B type. It is A type, it is B type. What about CH2? Number of protons on carbon are different. So definitely electron distribution will be different. इसका इलेक्ट्रॉनिक डिस्ट्रीब्यूशन यहाँ पर इलेक्ट्रॉनिक इन्वायरमेंट डिफरेंट रहेगा यहाँ पर प्रोटॉन्स के पास, CH2 वाले प्रोटॉन्स के पास, इसलिए इसका जो रहेगा तो वो आपका अलग रहेगा. तो अब देख लीजिए ये हो गया आपका C टाइप एंड NH के अंदर तो देखिए प्रोटॉन है तो definitely it will be different because this proton is attached to nitrogen. So it will be the D type. So you will get here 4 signals. You are getting here 4 signals. Is it clear? अब चलिए आप सिंपल सी और एक एग्जांपल लेते हैं. CH3, C, डबल बॉन्ड, O, सिंगल बॉन्ड, O, सिंगल बॉन्ड, CH3. Methyl acetate. Methyl acetate. ठीक है, methyl acetate. Methyl acetate. It looks similar because this CH3 and it is also CH3. So CH3 looks similar, but they are not similar in terms of electron distribution. Why? Electron density will be different because this CH3 is attached to more electronegative oxygen atom, while this CH3 is attached to carbonyl carbon. So both the CH3 groups, they are having different electronic environment. So the protons of CH3 attached to oxygen, it will be less electron density on the protons present on the CH3 attached to carbonyl will be slightly more as compared to the first one. So suppose it is A, then it is B, or it is A, then it is B. So you will be getting here 2 signals. 2 signals. So in that way, we can find out the number of signals. Now I write here another example. C6H5. Okay. यहाँ पर आपका हो गया CH3, सिंगल बॉन्ड CH3, सिंगल बॉन्ड CH3. आपको बताना है कि इसके अंदर कितने सिग्नल्स मिलेंगे, कितने सिग्नल्स मिलेंगे यहाँ पर इसमें, ये आपको यहाँ पर बताना है. तो अब देखिए कितने हैं यहाँ पर. ये है आपका A टाइप. It is attached to benzene. Benzene में next position is empty, means here proton is there. Then next one is CH3. Then again proton is there. Then again CH3 is there. Again proton is there. Means out of 6 positions of benzene, there are 3 methyl groups. They are present on alternate carbon. And the number of protons are 3. They are present on alternate carbons. So this proton, it is having CH3 group on both the sides. This proton, it is having CH3 groups on both the sides. This proton is having two methyl groups at its ortho position. So these three protons, 1, 2, 3, they are of first type. It will be the second type, B, 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 and B. What about this CH3? CH3 के दोनों साइड में प्रोटॉन्स है, ये CH3 के दोनों साइड में B टाइप के प्रोटॉन्स है, तो ये A and A. Therefore, we can say that you will get here two signals. CH3, CH2, here C double bond O, CH2, CH3. This CH2 attached to carbonyl, so it is different than this CH2. This CH3 is attached to CH2, then carbonyl. This CH3 is attached to CH2. Next is oxygen. So this CH3, they are not same. So it is suppose A type, then it will be B type. Suppose this CH2 is C type, then this CH2 will be our D type. So you will get here four signals. Tell me, what will be the number of signals in this compound, tertiary butyl alcohol? जल्दी से आपको कैलकुलेट करना है, नंबर ऑफ सिग्नल्स प्रेजेंट इन दिस कंपाउंड tertiary butyl alcohol. Suppose it is A. Okay, what is left here? 2CH3 containing carbon plus OH. Okay, what about this CH3? 2CH3 groups and one OH group containing carbon. Means if it is A, it is also A. It is also A, because here C containing 2CH3, one OH, and here OH is the second, B type. So you will get here two signals. So in this way, when you see the spectra of NMR, then first you have to find out the number of signals, and number of signals that depends on the different types of protons present, type of protons having different electronic environment. When electronic environment is different, their absorption or resonating frequencies will be different. And when their resonating frequencies are different, that in that condition you will be getting here number of signals. Okay, then next we will see what is the second point which we have to see is the height of signal. Height of signal. ठीक है, height of signal. चलिए, now, or you may see here integration curve. It will give the information. It will give information about number of protons in same electronic environment, same electron density, electronic environment. Number of protons in same electronic environment. Integration curve or height of the signal. Okay? So the height of the signal or integration, it will give the information about the number of protons present in the same signal. एक सिग्नल के अंदर कितने प्रोटॉन्स है ये बताएगा. फॉर एग्जांपल CH3 सिंगल बॉन्ड, पहली एग्जांपल ले लेते हैं हम इथिल अल्कोहल के साथ. ठीक है, so here there are 3 protons, they are identical, similar. Here number of protons are 2 which are similar, where here only 1 is there. So when you will get a spectra, then the height of the signal for CH3, it will be 3 times. 3 times for CH3 proton. For CH2, the height will be 2 times. And for OH protons, the height will be for one times. Suppose it is for OH proton, the height is 1 centimeter. Then for CH2, it will be 2 centimeter. For hydrogen, for CH3, it will be 3 centimeters. Means height will be increasing correspondingly depending upon the number of identical protons. तो एक सेट के अंदर, एक सिग्नल के अंदर जितने प्रोटॉन्स है वो हिसाब से उसका जो हाइट रहेगी, इंटेंसिटीज, इट इज ऑल्सो कॉल्ड एज इंटेंसिटीज, ओके, सिग्नल इंटेंसिटीज. सो इंटेंसिटीज बोलिए उसको, इंटीग्रेशन कर्व की हाइट बोलिए, या हाइट ऑफ सिग्नल जो रहेगी, दैट विल करस्पॉन्ड टू द नंबर ऑफ आइडेंटिकल प्रोटॉन्स. ठीक है, ये आप इसके ऊपर से कंक्लूजन ड्रॉ कर सकते हैं. ये जो हाइट होती है जैसे हमारे स्पेक्ट्रा में, तो ये क्या होता है, बिकॉज ऑफ सब सर्टेन नॉइजेस एंड अदर फैक्टर्स जो होते हैं मॉलिक्यूल के अंदर, फोर्सेस होते हैं, उसकी वजह से कभी कभी क्या होता है, ये एग्जैक्ट हमको हाइट नहीं मिलती है. यानी 3 सेंटीमीटर की बजाय ये मिलेगी आपको 2.9 सेंटीमीटर, यहाँ पे 2 मिली, या सपोज कीजिए 1.1 मिली. तो इस तरह से तो करस्पॉन्ड, यानी एग्जैक्ट हमारे को इट शुड बी मल्टीपल इन टर्म्स ऑफ फर्स्ट प्रोटॉन, जितनी भी है उसका मल्टीपल होना चाहिए, बट they are not exactly in multiple. So in that condition, a integration curve, a computer software is used which removes the side extra noises, etc., and it will give a clear cut idea about the integration. It gives the integration curve. So you will get this type of spectra structure in the spectra. It will correspond to the number of protons. So the height between these two horizontal parallel lines to the x axis, it will be giving the number of protons. So its height is measured in terms of centimeter, millimeter, whatever may be. The height will be the height between these two horizontal lines. It will give the number of signals for CH2 protons, and this height it will give the number of protons present in the CH3. So that computer software will be used to minimize the other irrelevant things, and you will get the exact value of that protons using this integration curve. So we can say that the height that correspond to, so now we have seen the different examples in our just previous examples, like here CH3 single bond NH, single bond CH2, single bond CH3. नंबर ऑफ सिग्नल्स के वक्त हमने देखा था एग्जांपल. तो यहाँ पर देखिए ये A टाइप, B टाइप, C टाइप, D टाइप का था. So what will be the height for this CH3, this CH3, CH2 and CH? तो अब इसमें से जो हाइट रहेगी, इंटेंसिटीज जो रहेगी, that will be intensities for CH3, it will be 3 times. For another CH3, 3 times. For NH, 1 time. No. And for CH2, it will be 2 times. Means suppose it is 1 centimeter, then it will be 2 centimeter for CH2. For CH3, it will be 3 centimeters, and it will be 3 centimeters. If you are getting the height, यानी आपने उसको इस तरह से एडजस्ट किया है, अगर इसकी हाइट 1 mm मिलती है, ये 4 mm मिलती है, तो इसका आपका 8 mm हो जाएगी हाइट. इसका जो है तो आपकी 12 mm you will get, and here for this you will be having 12 mm. So इस तरह से आपके तो उसकी intensities रहेगी, and that intensities will be used to find out the identical protons in a set. इसके बाद में आ जाइए नेक्स्ट इसके ऊपर, वो है पोजीशन ऑफ सिग्नल. पोजीशन ऑफ सिग्नल it is also called as chemical shift. Okay, chemical shift. Now, as I have already explained that the position of signal, it will be dependent on the resonating frequency of a signal proton. Now, for getting position of that signal, we have to use one reference compound. We have to use reference compound. Comparing the absorption frequency with this reference protons present in the compound will be giving the position of proton in our compound. And for that purpose, we are using TMS, tetramethylsilane, as our reference compound. Okay? What is tetramethylsilane? It is silicon with 4 CH3 groups. CH3 ग्रुप्स, ठीक है, 4 CH3 ग्रुप है, सिलिकॉन को अटैच है, तो ये टेट्रामिथिल सिलेन, ठीक है, टेट्रामिथिल सिलेन, इट इज यूज्ड एज ए रेफरेंस कंपाउंड, इट इज यूज्ड एज। इसके अलावा और दूसरे भी है, हम उसको आगे देखेंगे। फिलहाल हमको ये देखना है कि इसको हमको क्यों यूज करना है, इसका यूज करने के बेनिफिट क्या है। एक तो पहला सबसे हम देखते हैं, सबसे पहला पॉइंट हम देखते हैं कॉस्ट इफेक्टिवनेस, ये हमारे को एक्सपेंसिव है कि नहीं है, कम कॉस्ट में आ रहा है कि नहीं आ रहा, ये हम यहाँ पर देखेंगे। तो इट इज कॉस्ट इफेक्टिव, दैट इज इनएक्सपेंसिव, ज्यादा कॉस्ट नहीं है इसकी। सेकेंड पॉइंट कॉस्ट इफेक्टिव है, लेस उसका ये है, कॉस्ट कम है। सेकेंड पॉइंट इजीली अवेलेबल है, इजीली अवेलेबल है, इट इज इजीली अवेलेबल। चौथा पॉइंट, सॉरी थर्ड पॉइंट इसके अंदर ले लीजिए आप कि इट इज वोलाटाइल, वोलाटाइल है। अगर ये हम हमारे कंपाउंड के साथ यहाँ पर ऐड करते हैं, सपोज स्पेक्ट्रा लेते वक्त, और बाद में आपको वो कंपाउंड रिकवर करना है, लेस क्वांटिटी में आपका कंपाउंड है, तो इन दैट कंडीशन you have to remove that TMS from your compound to get the pure compound. So in that condition, you have to just slightly heat it. So this compound TMS will be evaporated, and you will get your original compound in pure form. So volatility is more another. So it is volatile. So it is easily removable from our compound to get the original compound in pure form. तो प्योर फॉर्म में अगर हमको ये करना है, वापस लेना है कंपाउंड, तो हम ले सकते हैं, इसलिए ये एडवांटेजियस है। चौथा पॉइंट ये है कि इट इज सॉल्युबल इन मोस्ट ऑफ द सॉल्वेंट्स used in NMR, for getting NMR spectra. Soluble in most of the solvent used in for getting NMR spectra. ठीक है, तो इसलिए सॉल्युबिलिटी का प्रॉब्लम नहीं आएगा आपका, यानी आपका कंपाउंड सॉल्युबल है और टीएमएस आपका सॉल्युबल नहीं है, तो ऐसी कंडीशन में प्रॉब्लम आ जाएगा। तो ये प्रॉब्लम यहाँ पर नहीं आ सकता है। व्हाई? बिकॉज TMS is soluble in most of the solvents used for getting NMR spectra. Number 5, fifth point is that all these 12 protons, CH3, they are identical, isn't it? They are having same electronic environment. Electronic environment means these 12 protons, they are equivalent. They are same, identical. They are same. So you will get a signal whose height will be high 12 times. Okay? कितनी रहेंगी उसकी intensity? It will be 12 times as that of one proton. 12 times रहेंगी उसकी height ज़्यादा रहेगी. So it will be visible. So that will be, it will be visible. in most of the spectra. ठीक है, मैक्सिमम स्पेक्ट्रा में it will be visible because of its high intensity. इंटेंसिटी ज्यादा होने से ये आपको है तो यहाँ पर, and the absorption frequency number second 6 point. These 4 CH3 groups, they are attached to silicon, and the electronegativity of this carbon and the silicon, if we compare, then carbon is more electronegative as compared to silicon, and therefore carbon silicon bonding electrons, they will be slightly more diverted towards carbon. यानी इलेक्ट्रॉन का जो वो रहेगा डेंसिटी, जो माइग्रेशन रहेगा इलेक्ट्रॉन डेंसिटी का, स्लाइटली कार्बन की तरफ रहेगा. तो कार्बन की तरफ है तो इलेक्ट्रॉन डेंसिटी बढ़ जाएगी, इलेक्ट्रॉन की जो डेंसिटी है वो वहां पर कार्बन के पास बढ़ जाएगी. ठीक है, कार्बन के पास इलेक्ट्रॉन डेंसिटी बढ़ेगी तो चारों कार्बन की तरफ बढ़ेगी सेम मैनर के अंदर, बिकॉज ऑल द 4 CH3 ग्रुप्स आर आइडेंटिकल. मतलब कार्बन सिलिकॉन बॉन्डिंग इलेक्ट्रॉन्स, दे विल बी स्लाइटली मोर attracted towards carbon atom owing to the more electronegativity of carbon as compared to silicon. अब जैसे यहाँ पर देखिए, अब इसको हम स्प्लिट करके लिखते हैं, सिलिकॉन की तरफ से आ रहा, यहाँ पर ये आपके पास कार्बन है, कार्बन को इधर से 3 हाइड्रोजन अटैच है, ये इलेक्ट्रॉन जब यहाँ पर इसके तरफ आएंगे कार्बन की तरफ, सो दे विल रिपेल कार्बन हाइड्रोजन बॉन्डिंग इलेक्ट्रॉन्स टुवर्ड्स हाइड्रोजन. So they will repel these carbon hydrogen electrons towards hydrogen atom. Similarly, these carbon hydrogen bonding electrons will be repelled towards the second. So another one is, so these carbon hydrogen bonding electrons, they will be pushed towards hydrogen atom. So these hydrogen atoms, they will be having higher electron density. Electron density will be higher. When electron density will be higher, then we will call these protons as shielded. So these protons, they are shielded protons. So they are shielded protons. Electron density इसके अतराफ में increase हो गई है. It is having more electron density. Therefore, we can say that these are highly shielded. So these 12 protons, we will call it as 12 protons. They are more shielded. They are more shielded. ठीक है, तो ये shielded हो गए, इलेक्ट्रॉन डेंसिटी इसके ऊपर ज्यादा होगी, तो इसकी जो है तो एब्जॉर्प्शन फ्रीक्वेंसी विल बी डिफरेंट. ठीक है, और ये जो हमने यूज किए टेट्रामिथिलसिलेन के अंदर, सो इसकी जो शील्डिंग है, ये तीनों इस तरह से प्रोटॉन्स की जो शील्डिंग है, ये ऑर्गेनिक कंपाउंड में इतनी शील्डिंग दूसरे कंपाउंड्स की बहुत रेयर केसेस में होती है. इसलिए बाकी सब के अंदर क्या हो रहा है, शील्डिंग नहीं होती है या कम होती है, या उसमें de-shielding होती है. They are either de-shielded or less shielded as compared to the 12 protons present in our TMS. That is why we are using it as a TMS is used as a reference compound for comparing the absorption or resonating frequency with our particular compound. So second point. Next point is that we will see here that the position of this will be dependent on its resonating frequency. So the resonating frequency of this, that is why the position will be treated as 0. It is treated as 0. The position will be treated as 0. The absorption frequency or resonating frequencies will be treated as 0. Okay? It is not 0. We are treating it as we are considering that we are subtracting these values with our reference compound, so that the difference between these two absorption frequencies or resonating frequencies between TMS and our particular proton, that will give the position of our signal in NMR spectra. ये पॉइंट आपकी समझ में आ गया? तो आज हम यहाँ पर स्टॉप करते हैं। अपने नेक्स्ट लेक्चर के अंदर हम आपको बताएंगे इससे आगे वाला पॉइंट, जिसके अंदर आपको ये बताएंगे कि उसको मेजर कैसा करते हैं पोजीशंस को, और कौन कौन से फैक्टर्स है, उसको केमिकल शिफ्ट क्यों कहा जाता है। ये पॉइंट हम तो अगले इसके अंदर बताएंगे। एंड आपकी जानकारी के लिए ये बता दें कि ये जो वीडियो है हमारा, ये YouTube के ऊपर अवेलेबल है। ये आप हमारे YouTube चैनल के ऊपर से डाउनलोड कर सकते हैं, उसमें देख सकते हैं। चैनल को सब्सक्राइब कीजिए और उसके पास एक बेल बटन आपको दिखाएगा, बेल दिखाई देगी, उसके ऊपर आप क्लिक कीजिए तो आपको रियल टाइम के अंदर जैसे हमारा नेक्स्ट लेक्चर या हमारा वीडियो अपलोड होगा तो यू विल गेट द इंफॉर्मेशन अबाउट आवर न्यू वीडियो।